Hello guys, welcome back to my YouTube channel. Today we are going to discuss about containers and virtualization. Okay, so both of these technologies are used in computing to improve the resource utilization, to enhance the scalability, and to isolate the applications or services from each other. Okay, while both of these technologies are sharing some similarities, but they are operating at different levels of computing stack and have distinct characteristics. Okay, so let's read about virtualization. What is virtualization? So virtualization involves creating a virtual representation of physical hardware, such as you can take example of servers, storage devices, or network resources. Okay, so it enables the creation of multiple virtual machines on a single physical machine. Okay, it involves the creation of multiple virtual machines on a single physical machine, and each machine running its own operating system and application. Okay, and these VMs virtual machines are completely isolated from each other and behave as if they were running on separate physical machines. Okay, so during COVID time everyone uses HVD to work, right, for their office work and all these things, right? So this is the example of virtualization, like VMware. You can take the example of VMware. Okay, so now let's read about the key features of virtualization. So first is hypervisor. Okay, so hypervisor is also known as virtual machine monitor, and this hypervisor is a software layer that abstracts physical hardware resources and manage the allocation of these resources to virtual machine. Okay, this is hypervisor. And isolation simply means virtual machines are completely isolated from each other. Okay, providing strong security boundaries between different applications or tenants, right? And flexibility is also one of the key feature for virtualization. So virtualization allows for running multiple different operating system and applications on a single physical machine, providing flexibility in deployment and management. Okay, so this is the third key feature of virtualization. And one more key feature is resource management. Okay, so in virtualization, platforms often include features for dynamically allocating and adjusting resources such as CPU, memory, storage among virtual machines based on demand. Okay, so these are the key features of virtualization. Okay, so I hope that you guys are clear. Now let's read about containers. What are containers? So containers provide a lightweight form of virtualization. Okay, since this is lightweight form and this is heavyweight, right? Because in this we are going to use operating system of a physical machine. Okay, and from the same physical machine we are going to allocate memory and all these things. Okay, so it is a heavyweight technique, and while containers, it is a lightweight form of virtualization at the operating system level. So here see reason. Unlike virtual machine, containers share the host operating system kernel and do not require a separate operating system installation for each container instance. Okay, but here in the case of this type of virtualization, we need a separate operating system. Okay, for our virtual machines like HVD, or you can say VMware. Okay, but in case of container we don't require all these things. Okay, so unlike virtual machines, containers share the host operating system kernel and do not require a separate operating system installation for each container instance. Instead, container package application and their dependencies into portable isolated unit called images. Okay, instead, containers package applications and their dependencies into portable isolated units called images. Okay, and what are the key features of containers? So one is container engine. Okay, so container engines, the example of container engines are like Docker, Podman. Okay, so these container engines are used to build, run and manage container. Okay, they provide tools for creating, distributing and running containerized application. Second key feature is efficiency. Containers are lightweight and consume fewer resources compared to virtual machines because they do not require a separate operating system instance for each container, right? And one more feature is portability. So container images can be easily moved from different environments such as development, testing and production. without modification, ensuring that consistency across the software development lifecycle. Next feature is scalability. Containers can be quickly instantiated and scaled up or down to meet the changing workload demands, making them well suited for microservices architectures and cloud native application. Okay, so when there is a huge demand, then it automatically increases its size to meet the expectation. Okay, so in the end, let's read the summary. So both virtualization and containers offer ways to improve resource virtualization and isolate applications. They operate at different levels of computing stack and have distinct characteristics suited to different use cases and deployment scenarios. Virtualization provides full isolation of the at the hardware level, while containers offer lightweight portable encapsulation at the application level. Okay, so I hope that you guys are clear with this containers and virtualization video.